All right. Well, congratulations. You've made it to the end of this particular series. We certainly have introduced some perplexing questions. And now I'm sure you're looking for some answers about what really is the nature of quantum reality. I would leave this statement that Richard Feynman, a famous physicist, said, I'd rather have questions that can be answered than answers that can be questioned. What's going to happen is as you gain more understanding, it also introduces more questions. So let's do a quick summary of how we got here, and let's look into what physicists say about the nature of quantum reality. So in the dual slit experiment, we saw that whether we are observing matter or measuring it, or not observing or not measuring it, matter behaves differently between those two states. In the non-observation state, it's a wave, and in the observation state, it's a particle. Well, this leads to the question of who's watching who, and we said there's a couple different options. It's us watching the atomic world watching us, or we're both watching each other. The quantum eraser experiment and the quasar experiments with its separation between detector and light source of 10 billion light years blow up our understandings of the past and the future, and we're forced to consider only now an eternal now. And the entanglement experiment based on spin, where two particles are forever linked together independent of space and time. All right, quantum reality. So now after all of these interesting ideas, you're probably thinking, well, we finally get to the point where you can make sense of all of this. But as you probably have read from the title, it says quantum reality, one of 8 different theories. Now you become a little suspicious. And you'd be right to be suspicious, because these questions are not easily answered, and physicists have dealt with it in 8 different interpretations. And what I've done here is I've summarized these 8 interpretations from Nick Herbert's book, Quantum Reality. Now, he spent chapters on this, and what I wanted to do was try and take a few pieces of each one of these theories to highlight the differences between them and what their focus is. And hopefully this gives you a good summary of how the different interpretations are different from each other. But certainly if you are interested in it, Nick Herbert's book I recommend, but there are other books, and you can delve into it yourself and try and make your own decisions about what you think might be happening. Now in this particular slide, you'll see that I have this purple area with the green atoms icon right here, and this is to signify the deeper reality, this atomic quantum world we've been talking about. And above it is the world that we're familiar with. I put a pizza there because we're going to have pizza for dinner, so that has a reality for me. And also mountains, because mountains are one of these structures in our world that stay there for eons and eons. So, first one, Copenhagen interpretation, part 1. So here the scientists don't speculate about this deep quantum reality. They say that atoms are not things. So an example is a rainbow can be observed, but it's not a thing. A rainbow is the interaction of sunlight with raindrops. Take away either the sunshine or the raindrops and the rainbow disappears. So it's really the result of an interaction between two things. And so that's kind of their thought, is that there's no measurement, no attributes. The measurement devices have a special status since they determine the attribute of the atomic particle will manifest. This is the most accepted theory by all textbooks and scientists working with quantum mechanics. So for the most part, they really don't speculate. They say there's no way that you can really speculate what this deep reality is. It's, in a sense, unknowable. So, theory 2 of 8, Copenhagen interpretation part 2. The focus now is on the observer as a special status to determine what attribute the atomic particle will manifest. So there's no real elemental phenomenon that is real until it is observed. the universe is in an indeterminate state before observation. So the observer brings about the reality of the atomic world. The delayed choice experiment, the quasi-experiment, the observer created the present as well as the past attributes because of the way that they set up the experiment. So if you set up the experiment one way, the past is manifest in one way. If you set up the experiment in a different way, the past will manifest in an alternative way. The issue that they have with this theory is that there's no agreement as to what constitutes an observation. Theory 3 of 8. Reality is an undivided whole. This reality is a seamless whole that is non-local. When two particles interact, the phases do not disentangle. They are forever entangled. This reality is not an ordinary space, but is a configured space. Particle A and B are not separated in this space, but are part of the same wave shape. So in this theory, they come up with a special space that's called configured space, where these particles are forever interacting, because in the space that we are familiar with, they are separated too far in distance to be able to interact without going beyond the speed of light. John Bell's theorem and entanglement strengthen the non-local aspect of nature and support this theory. Now, in theory 4 of 8, this is called the many-world interpretation. Some of you might have heard it about the called or reference to multiple universe solution. Physicist Hugh Everett proposed that every possible outcome is a reality, but in different universes. So if there are 5 possible outcomes, there are 5 different universes. Even the most improbable event in this reality is captured in some universe. Humans can only observe one of these universes. The other ones are not observable. And this is a favorite theory amongst theoretical physicists. So theory 5 of 8 is quantum logic. This reality obeys a non-human kind of reasoning. It's a new logic of how attributes of the atomic world combine to create new attributes. Uses a concept called wave logic. This approach has had little impact on practical physics since it is neither concerned with the nature of reality or the definition of experiments. So it's included in here, but it really is not one that has been embraced. Theory 6 of 8 is called neorealism, and here the world and this reality is made up of ordinary objects, so atoms are things, and David Bohm rewrote his quantum mechanics text to align with this theory. Originally, his first quantum mechanical textbook was aligned with the Copenhagen interpretation, but after talking to Einstein when they were both professors at Princeton, he rethought his approach and came up with this neorealism approach. So atomic particles are very sensitive to the environment, which includes all of reality. His model has a pilot wave which instantaneously communicates any change to the atomic particle, allowing it to change instantaneously. Theory 7 of 8, this is called the conscious created reality. The universe only acquires definite values for dynamic attributes when a conscious observation is made, and the focus here is on conscious. It's different from the observer-created reality, which was mentioned previously, where the observer or the device that's making the measurement does not have to be conscious. So here the focus is that consciousness has an important part on determining the reality that the atomic world manifests. All possibilities shrink to one outcome when there is a consciousness that observes this reality. The question is, where do all the possibilities collapse into one reality? And one suggestion is that it's in the mind of the conscious observer. Now, the last of these 8 different theories is the Duplex World theory. And you would think that maybe we had left the last reality to be the best description of reality, but actually it's the opposite. It's the one that's not really fully developed, and it was started by Heisenberg, one of the initial architects of quantum mechanics, where atoms are half real, and it works with the difference between the quantum world's unmeasured possibilities are not as well defined as classical probabilities are. I'm not going to go into it, but I wanted to include it because in Nick Herbert's book he highlights these 8 different theories, and I wanted to put it in here for completion. And so, as we've gone through these, there's not enough information in all 8 descriptions here to give you a full understanding of the depth of each one of these theories, but hopefully there's enough information to tell you that there's some theories which say that the world can't be defined well. It's undefined until there's an observation. Some people believe that this observation has to be conscious. It's not sure where all of this reality collapses and then appears as a particle to us. There's some that saying, no, actually the world is understandable. It's made of ordinary objects, but then you have communication between particles to determine what's the right outcome that has to happen at faster than the speed of light. And then there's the many worlds interpretation, where every possibility that the atom or the atomic world can manifest is a reality in some universe. And so these are pretty interesting ideas. Obviously, the physics community is quite divided on what quantum reality is, as you can see by these 8 descriptions here. But it's worth at least reading about them and doing some of your own research and trying to make your own opinion based on what you've read of how you think reality might be constructed and how we might be able to understand the quantum world better and how it manifests with all its interesting anomalies. And after all, your body is constructed from this atomic world and this reality, so you are clearly part of this reality. And if you've come to the end of this series and you found that you've had to go back or plan to go back and listen to some of these videos again, don't be surprised. Learning to visualize these realities that we've talked about regarding space and time and matter, specifically quantum theory, takes a bit of practice like any skill. So right out of the gate, you probably get some insight and some learning. And as you go through each time, you're able to visualize and build up your own models in your head better and better. Because it definitely takes a bit of practice. It's the same as learning a skill in music or sports or anything else. You have to approach it a couple of times to develop the skill, and it's the same with your mind. You're just stretching your mind a bit to be able to visualize all of these concepts. Yeah, so that wraps up this series, and this wraps up this video. I hope you've enjoyed it as much as I have enjoyed putting this whole series together. And we'll continue in a few more series that I will talk about in the next slide. So where do we go from here? We've just finished the Matrix of Time series. This was an introductory series. The videos that you've been watching are related to time, space, matter, motion, quantum theory, and quantum reality. So where it goes from now is I'm going to split it into 2 series. The first one will be the expanded concepts of time series, and here we'll actually continue on with the exploration of space and time by using the ideas introduced in quantum reality of neorealism in multiple universes. So this series will explore the implications to physics of a universe with multidimensional time, and we'll try to look and see if this could explain some of the issues that physics is struggling with. While this series does get more and more technical, as much as possible, I try to explain the concept so that non-technical people can follow along. And if you are non-technical, you can just ignore the more technical parts where equations will be introduced, and I think you'll still get something out of it. And then the third series will be human perception of space and time, and these videos will cover the implications of the concepts introduced in the introductory series, but now to human perception. And this series is sure to open your mind to our relationship of time. I suspect that this series might be of more interest to the non-technical people than to the technical people, but I encourage everybody to at least listen to the videos and keep an open mind. So that wraps up this introductory series into the matrix of time. I hope you enjoyed this as much as I enjoyed putting this series together, and you decide to continue watching new episodes as I post them to this channel. Okay, thank you very much. If you'd like to watch more of the Matrix of Time videos, please hit the subscribe button and you'll be notified of new presentations. You can also visit my webpage at www.multidimensionaltime.com, and in there you will see a reference to a book I've written that you might be interested in. Also, I have a page with technical papers. There's an intro paper, and there is a paper called Three-Dimensional Time and Consciousness in the technical section that'd be of interest to people with and without a technical background. And then the rest of the papers require an engineering or science background because they get quite technical. So again, please hit subscribe and join me in not only future videos of this Matrix of Time. There will also be other series related to space and time that I'll be doing in the future, and you'll at least be notified of those as well. Okay, thank you very much.